Proportions involve four quantities that are somehow all related. The following objectives are important to setting up a proportion. First, you'll want to identify when two situations are similar in some way, and there are clues to look for to see if that may be the case. You want to determine if the situations actually are mathematically proportional. And I'll talk briefly about what that means. We'll want to arrange the quantities in the proportion so that each is in a correct position relative to all the others. Below are two similar situations that may be proportional. For cooking, 1 cup of rice should be mixed with 2 cups of water, and 3 cups of rice should be mixed with 6 cups of water. These quantities are all placed into a correct proportion in the figure. So when we set up a proportion, the quantities that are above and below each other have to have something in common. They must have some clear relationship. And also, quantities which are directly across from each other have to have something in common as well. Let's look at all the combinations of the different quantities and see what they actually have in common, and we'll see why this proportion is valid. So one thing that jumps out at me about the numerators here is that they share the same units. And that's going to be what they have in common. They are both rice. Let's see if the denominators have something in common. They are both water. They are both of the water type. All right, so that's critical. Things across from each other have to have something in common. But also, it says that things which are above and below each other have to have something in common too. So what do these have in common? So these would both belong to the smaller batch, where the 1 cup of rice here gets literally mixed with those 2 cups of water in a single pan. That's what they have in common. Similarly, over here, 3 cups of rice would mix with those 6 cups of water to make the larger batch. Also notice that diagonal quantities will have the least in common of all. So whereas this is rice, the quantity that's diagonal from it is of a different unit. It's water. And also, whereas this cup of rice would go in the small pan, the 6 cups of water would go in the large pan. So they really have nothing to do with each other, and that's why they're diagonal. Now, how do we truly know if two situations are really mathematically proportional? There are always going to be two variables involved in a proportion. In the above case, the volume of rice and the volume of water are the variables that are changing. So if the volume of rice is proportional to the volume of water, then we can write that with a proportional symbol which looks sort of like a fish. V rice, the volume of rice, is proportional to the volume of water. Now what that implies is several things. It means that a graph of the two variables involved must pass through the origin. So when the volume of rice used is 0, we should also find that the volume of water required would also be 0. And they're going to make a nice linear graph as well. Okay, so let's say I put the volume of water on the horizontal axis and the volume of rice on the vertical axis. They would make a nice straight line through the origin, and a formula which describes that mathematical line would be this. the volume of rice equals some kind of slope constant times the volume of water. Those are the conditions we look for when we have a mathematical proportion: linearity and passing through the origin.